Hello there. Okay, so today we are going to work a little bit on some formulas in Module 8 of the HMH, right? So here is a worksheet that I gave at the beginning of the class from Hill Tutoring, and I'd like you to pause and then see if there's anything you can do on it without me before I help you out with where to start. Okay, welcome back. So where to start would be with our exponential growth or decay equations, right? Functions. So I'm going to write them right up here at the top of the paper. We're going to go y equals a 1 plus r to the t. This would be for growth. Or you could do y equals a times the quantity 1 minus r to the power of t. And this would be for decay, when something is declining, decreasing, depreciating, okay? Now, if that helps, pause and try again with what you can or cannot do. Okay, welcome back. So, if you buy a house for $130,000, it appreciates, that's going to be growth. At 6% per year, how much is it worth in 10 years? So our initial amount is $130,000. It is growth at 6% in decimal form, that is 0.06. We take the decimal in the percent and we move it 2 places to the left. That's how we get the 0.06. I also like to put the time even though we don't have a box for it, so 10 years. And then I'm going to plug these numbers into this equation for growth. So we get y equals 130,000 times the quantity 1 plus 0.06 to the 10th power to show our growth. And then you plug that into the calculator. I like to plug this in first, add it together, and then do 1.06 to the 10th power. And then multiply that times 130,000, and you should get $232,810.20. Dollar sign goes at the beginning in the United States. Okay. I know lots of other cultures put it at the after the change, like where you say it, but of course we have to be weird, right? All right, number 2. Mr. MD is losing 20% of his hair each year, poor guy. If he currently has 1,546 hairs on his head, about how many hairs will he have left after 10 years? So again, we have time is 10 years. This is a decay because he is losing hair. Initial amount was 1,546. So when I get my answer, I want to double check that it's logical, right? So my answer should be less than 1,546. Just like number 1 was a growth rate, and the answer, 232,000, was bigger than my starting rate. Our rate for losing hair is 20%. Changed to a decimal is 0.2. You can write 0.20, but the second 0 is not necessary. Kind of like this 0 is not necessary. All right, the function is going to be y equals 1,546 times 1 minus 0.2, all to the 10th power. Try to plug it in without me. Welcome back. You should have gotten 166 hairs. Number 3. If you invest $40 in an account for 10 years at 3% interest rate, how much money will you have? All right, so we've got our time equals 10 years. Our initial amount is 40. It is growth. 3% is our interest rate, which is 0.03. All right, so that's going to give us y equals, original is 40, so a is 40, 1 growth rate, 1 plus our 0.03% rate, right? And then to the t is 10 years again. So when you multiply that out, you're going to get, I think it's 53.7566. I'm so sorry if I'm off. But I want to talk about how to round that, right? We're talking dollars, so we're going to round to the pennies column. We look to the right, it is 5 or more, so we up the score, so we add 1 penny. So the correct answer is going to be $53.76. All right. A population of 100 frogs increases at an annual rate of 22%. How many frogs will there be in 5 years? So our initial amount is 100. We are increasing, so it is growth. Our T is 5 years this time. Percent is 22%, so 0.22. Our function is going to be y equals 100 times 1 plus 0.22, all to the 5th power. And this would give us 270.27. You are welcome to argue that we would not have 0.27 of a frog, so I would also accept 2.70. You could also argue that since it is increasing, that the 2.7 is a better guide to tell us that we're going towards 271. So I would actually also accept 271. Make sure you chat with your teachers about this and how they would handle it. I would like to comment that if our answer had been 270.27746 or something like that, and you rounded to the hundredths column, unless the directions told you to, I would mark this wrong, because there's no reason to round to the hundredths column. It makes sense. There's a reason to round to the ones column because you don't do partial frogs. But if you round to the hundredths column, I'm going to think you just treat everything like it has pennies. And frogs don't have pennies, so like there's no purpose to rounding there, unless the directions said to round to the hundredths column, right? So be careful on that. All right. The other side has more. I did not go into detail on this side in class, so do as many as you can or want to build your confidence. But I'm going to go on to talk a little bit about other things we did in class today. So the next thing it's really important for you to do is to update your notebook. So we did a full page today of notes for just Module 8 formulas or equations. All right. I'm going to start with compound interest when it is compounded yearly. That equation is A equals P times the quantity 1 plus R to the T power. All right. And A is our amount with interest, so like your principal plus your interest earned. P is principal, and I am not confident on which way to spell principal for this. So I think it might be this kind of principal. Even though I know this is like for principal of your school, I think it also means like the beginning principal, but it might be principal like this, like the main principle of something. So if someone wants to fact check me on that, put it in the comments, that'd be great. All right, and then we've got R equals rate. It's usually given as a percentage, so we need it as a decimal, so you'll have to do that converting. And then T equals time in years. Time does not have to be in years for exponential growth and decay, but it does have to be in years for compound interest yearly. All right. But then sometimes it's not yearly, so we have a different one for that. We have compound interest not yearly is going to be almost the same. It is A equals the principal times the quantity 1 plus R over N to the power of N times T. And that is where n equals the number of times it is compounded in a year. So, for example, I'll give you a couple of examples. So, monthly, if you're getting compounded monthly, then n would equal the number of times it's compounded in a year. Well, if it's compounded once a month, then n would equal 12 because there are 12 months in a year. All right? If it is compounded daily, then n would equal the number of days there are in a year, so 365. Or maybe it's going to be compounded quarterly, so then n would equal, how many quarters are there in a year? Well, how many quarters are there in a game or that doesn't count. I think some games mess you up. But in a dollar, right, there are 4 quarters in a dollar. So quarterly usually means you've divided it into fourths, so n equals 4. But hang on, because maybe you're going to compound the interest continuously. Then you're going to use this formula where the amount equals the principal times Euler's number to the rate times time. So remembering that E equals Euler's number, even though it's spelled like Euler, it sounds like Euler's number. And what is Euler's number? We find it on the calculator. It's like 2.71 or 76 or something like that, but we just use the calculator button for it, kind of like pi, right? Now let's go ahead and do the equations that we were just working with, right? Do you remember what they were called? So these are going to be equations or the formulas for exponential growth or decay. All right. So our growth formula is y equals a times the quantity 1 plus r to the t. But then the decay equation would be y equals a times 1 minus r to the t. And this is where A equals the initial amount, R equals the rate as a decimal again, and then T equals time. Notice I don't write in years here because the time can be different. All right. And then, just to make sure we have it in writing in case you need it while you're testing, let's review how to change a percent to a decimal. So, to change percent to decimal, move the decimal 2 places to the left. And let's look at a couple examples of that. So if you have 25%, right, the decimal is here, and we would move it 1, 2 to the left, so we would get 0.25 as our decimal. I am going to go ahead and erase that so it doesn't mess you up if you're just looking at it, right? Another example would be 4%. If this is your decimal, move it 2 to the left, we get 0.04. And many people put a leading 0 out there in the ones place. I do prefer that, but neither is more correct than the other. What if we add something more complicated, like 8.75%? Again, here's your decimal, you're moving 2 to the left, So it would be 0.0875 because you cannot have two decimals in a number. What if it was weirder than that and it was like 0.32%? Well, you're still going to take this decimal and move it 2 to the left. So we would get 0.0032 would be your decimal. Okay, so next I'm going to show you the exit ticket that we did, or not the exit ticket, the problems we did as a class today, so that we can see what that would look like. So I'm going to have to write a few things down so that I have the problems, which would be a good time for you to pause and try it on your own. Oof. Oh, that's not what I wanted. Oh, I'm so sorry. Give me a second. I want to pause recording. Okay, so I'm not even sure if I showed you the screen, so I'll try to do my best. So it says you have $1,000 to put into a bank account. So like you go to a bank and you're like, hey, I want to deposit this $1,000 into savings. And they're like, sweet, our rate is 4.09%. And you're like, cool, and you plan to leave it in for 6 years. And then the bank is like, cool, do you want to sign up for continuous compounding interest, monthly compounding interest, or yearly compounding interest? And then the question actually asks, how much more will one of them give you than the other? So we're going to use our compounded interest continuous formula. So we're going to do the amount equals PE to the RT. Then here we're going to use the amount equals P times 1 plus R over N, where N is monthly, so it's going to be 12, and then times 12 times T. And then for yearly, we'll do the amount times the principal times 1 plus R to the T. And so then we can plug in all of those numbers. So let's go. We go A equals $1,000 times E. I'm just going to plug that into the computer. And then this in decimal is 0.0409. So 0.0409 times 6. All right. And then I'm going to plug that in, see if I can show you as I plug it in. We'll see if it shows up. Okay, so we get, I'm going to start with just the E and then multiply times 1,000 at the end. So on our calculators, you hit Shift and then the natural log button, which has an E to the exponent of. And you can see my exponent is ready. So I'm going to go 0.0409 times 6. I'm double checking that the times 6 stayed as the exponent, which it did. That equals that. And then times my $1,000. And that equals 1278.132464. This is money, so I am going to round to the hundredths place, or the pennies. I look to the right. 2 does not change my 3, so the answer for continuous is $1,278.13. And now we're going to do it again for monthly. So I plug in the numbers. Let's see. A equals 1,000 times 1 plus, and then we have 0.0409 over 12. And then 12 times 6, right? Because 6 is our years, is our time. Now, you need to make sure that you are dividing this before you add the 1, okay? So I'm going to do that like this, clear. 0.0409 divided by 12 equals, and then I press the SD above ours. Then I'm going to add 1 plus 1. That gives me that. Now I need to put that to an exponent. Ooh, I'm not sure what this is going to do. Now I know 12 times 6 is 72, so I would really just put 72 in there. But we could see, no, I'm just going to put 72. I don't want to have to repeat my steps if I'm wrong. That equals that, 1.2777, but I got to multiply that times 1,000. And we get $1,277. And, ooh, this is a good one. Let me write it over here so we can talk about rounding. 1,277.599268. This is money, so I want to round to the pennies column, the hundredths place. I look to the right. It is a 9, 5 or more. We up the score, so I'm going to add 1. 9 plus 1 is 10. So I end up with a 0 here. Carry the 1, so I get a 6 there. So it will be $1,277.60 for rounding. All right, and then we do it one more time for the yearly. I'll come down here. I'll do it right below. The A will equal 1,000 times 1 plus our rate is 0.0409. All of that to the 6th. I can do this adding in my head, right? So we get 1.0409 to the 6th power equals that times 1,000 equals, sorry, it wasn't showing before, equals that. So we get 1,271.903174. It's money, so I'm going to round to the pennies column, which is the hundredths place because there are 100 pennies in a dollar. And I look to the right, it is less than 5, so my 0 stays the same, giving me $1,271.90. So your main question is, what is the difference, though, between saving continuously, being compounded continuously or being compounded yearly? So we're going to go 1,278.13 minus 1,271.90, subtract those, and I believe you get $6.23, which is the difference between doing it continuously or yearly. And you might think, Ms. Heathcote, it was not even worth $6 to do all that math. But what if instead of $1,000, you were putting in $100,000, right? That means that this would be $623. Now, is it worth it to do it continuously versus yearly? If not, what if you had $1 million, right? Like, think of it in bigger numbers. What if you did it for 16 years instead? Like, $6.23 might not seem like a lot right here in this example. But if anything gets bigger, your deposit gets bigger, your time gets bigger, your percentage gets bigger, any of those change, $6.23 might add up. All right. Number two said that you bought a car for $32,000 and that it depreciates. Let's make sure I write that word. Depreciates at a rate of 9%. So that word depreciates tells me that this is going to be a decay problem. All right. So I kind of just go over to my notes that we took for formulas, right? And I see a decay. I'm going to use that formula and plug in my numbers. So we have y equals a times 1 minus the rate, all to the t power. My a is what I started with. So I started with a car that's valued at $32,000. And then I multiply it times 1 minus, let's do the 9% in a decimal, will be 0.09. So minus 0.09. All of that to the 7 years. And then you just plug it in on a calculator. 1 minus 0.09 is going to be 0.91. And we're going to take that to the 7th power. And we get that. And then we're going to multiply that times the $32,000 that the car started its value at. And that's going to give us 16536.35262. I'm going to put a comma here so that I know it is 16,536. We are talking about dollars, so this is money. So we are going to round to the hundredths place, the pennies column. Looking to the right, it's a 2, so I do not change the 5. So our answer will be $16,536.35. So after 7 years, you get about half of what the car was worth. Or you can also think about it that you spent $16,000 right around, right? Because it's about half. You spent $16,000 to drive that car for 7 years. All right. Well, let's do the last one. The last one said that you deposited $130 into a savings account, earning 9.4% interest that is compounded quarterly for 2 years. So on this problem, it's going to have the word compounded. So that's how you know to use our compound interest formula. We're going to use this one because it's doing it quarterly. So our n is going to equal 4, and we will use this formula. So the formula we are using is A equals P times the quantity 1 plus R over N to the N times T. All right, amount is what we want to know. Our principal is only $130. 1 plus, I got to change this into a decimal, 0.094. 0.094 over 4, because our n equals 4 when it's quarterly. And then n again in our power to the power of 4 times 2 years. This part needs to be done first before you add, so I like to just do that on the calculator and then add. So I'm going to go clear. 0.094 divided by 4 equals 0.0235. And then I'm going to add 1 equals 1.0235. Now I have to take it to the 4 times 2. So I'm going to go exponent. 4 times 2 is 8. So to the 8th power, I get that. And then I'm going to multiply all of that times 130. And I get 156.547497. But this is money, right? We started with $130. We now have $156. But we don't do money out this far. We stop at the pennies column, the hundredths place. I look to the right. It is 5 or more, so I up the score. So I add a penny. The correct answer would be $156.55. Dollar sign is on the left. And there you go. And then we took a quiz on this today. So I hope you feel prepared.